Today we're in Unit 3, Polynomial and Rational Functions. So we're going to start out with Section 3.1. Section 3.1's title is Quadratic Functions. And models. Okay, when we talk about quadratic functions, we say that quadratic function, to make it quadratic, we've talked about quadratic trinomials. So quadratic means that it has to have a degree of 2. So we'd be looking at something that says f of x equals ax squared plus bx plus c. Now, they also add a cannot be 0. So I'm going to give you a second to think about that. Why would a not be 0 to be a quadratic? All right, so everybody got what they think it is? Well, if a is 0, then this would make this be f of x equals ax squared plus bx plus c. But if a is 0, then this whole thing goes away and becomes 0. That's if a is equal to 0, cannot be 0, because if this is 0, then what kind of any function does it have now? This would be f of x equals bx plus c, because the a is 0, multiplying makes that go away. So this becomes a what kind of function? It becomes linear, not quadratic anymore. So that's why we have the a not equal to 0. Okay, we also have a quadratic that can be written in a different form. So f of x equals ax squared plus bx plus c can also be written in standard form as f of x equals a x minus h quantity squared plus k. So we take completing the square on the one that's in this form, and it'll make it turn into the one that's in this form. So we do that by completing the square. Now, one thing we know about the a in both of these two formulas is that if a is positive, so this means positive, then if it's positive, then the parabola opens up. So this is a picture of a parabola. It opens up where the vertex is at the bottom. If a is less than 0, meaning that a is negative, then we know that it opens down. So the vertex would be at the top in that case. Now, the graph in standard form, this h and k is the vertex. So again, the vertex is this lowest point or this highest point. So now we're going to look at an example where we use completing the square to put it into standard form. So the example is going to be f of x equals 2x squared minus 12x plus 13. So this is a quadratic trinomial. You've got 3 terms, so it's trinomial. And we're trying to rewrite that in terms of standard form, the HK version. So this is going to be ax squared plus bx plus c. So as we go down, the first thing we're going to do is we're going to move c to the right. So I get f of x equals 2x squared minus 12x, and then I'm going to put plus 13 over here. So the next thing I do is I take out the coefficient on here, so I get f of x equals 2 times x squared minus 6x. I still have my plus 13. Now notice there was an x in common too, but I wanted to have this to be out something that we could factor because we're trying to complete the square. So the first step was to move c to the right. The second step was to distribute out the a. Okay, so this would have been the a, the 2. The third step now that we've done those two things is going to be to take half of b, so 1/2 times b, square that, and then add it inside the parentheses. Okay, so half of b, half of -6 squared is going to give me what? Half of -6 is -3. -3 times -3 is positive 9. So we're going to put a plus 9 right here. Now, when I put a plus 9 on the inside, I can't just arbitrarily add stuff inside without doing something to make it stay even. So I have 2 times 9 is what I really added on. So if I add 2 times 9 or 18 over here, then I have to, over on this side, subtract 18. So I'm going to subtract 18 on this side. So I get f of x equals, so here let's go ahead and finish this out. So number 4, we're adding it inside the parentheses. And then subtracting it from the c. So now we factor. So we have 2 out front, and this factors into 2 sets of parentheses. So it's like a reverse FOIL. 13 minus 18 is going to give me a -5. So I have x and x to be x squared. Factors of 9 that add to be 6 would be 3 and 3. 3 times 3 is 9, but adds to be 6. But the 6 is negative, so we make both of them negative. Now, we know these two are going to come out to be the same because we made it to be that way. We've completed the square now. So this is going to be 2x minus 3 squared minus 5. So that's in the standard form. F of x equals a x minus h squared plus k. So to get that, now we can find the vertex. So we've got this is in standard form. Now we're going to find the vertex. And we said before that the vertex was hk. So if I line these up, the x lines up with the x, the minus lines up with the minus, so the 3 lines up with the h, so the h is going to be 3. The k is going to be plus a -5, so we get -5. So that would be my vertex. Now, the next thing that we're going to find so that we can see about graphing this thing with another thing besides the vertex, we're going to find the x-intercepts. And we're going to find the y-intercepts. Now, the x and the y-intercepts are where it crosses the axes. So what do we know about each thing that crosses the x-axis? Every point on the x-axis has y equal to 0. So in this case, we want to make y equal to 0 to find the x-intercepts. The y-intercepts, everything that's on there is going to give me the x equal to 0. So if I look up into my original equation, so let's write it down here, 2x squared minus 12x plus 13, that's equal to f of x. If this is equal to f of x is another way of saying y, right? So if I want to get the x-intercepts, I'm setting y equal to 0. So I have 2x squared minus 12x plus 13 equals 0. Now to solve this, you might try to factor, but we're going to go ahead and just do quadratic formula. So I have x equals negative b plus and minus the square root of b squared. Now notice I'm putting the b's with the negative signs in there. I'm putting them inside the parentheses, so when I square it, minus 4 times a times c all over 2 times a. So this is be 144 minus this, what would that be? 8 times 13, so 104, so we get the answer to come out to be 40. So I've got 12 plus and minus the square root of 40 all over 4, 2 times 2. So we end up with 4 comes out of the 40, right? So we have 12 plus and minus 2 square roots of 10 over 4. And then we can cancel some things out here. 4 goes into 12, and 2 goes into 4. So we would get, let's just take a 2 out. So if we take a 2 out, then we're going to get 6 plus and minus square roots of 10 over 2. So if I put that in my calculator, these are my what? I set y equal to 0, so these are my x-intercepts, right? So my 2 points are going to be 1.42, 0, and 4.58, 0. So notice the y is equal to 0 on the both of them. So these are my x-intercepts. Now, looking at the original equation again, this time it's even easier, because now if I'm trying to find the y-intercepts, then I let all the x's be 0. So I'm going to have f of x, or y, equals 2 times 0 squared, because I'm plugging in for x, minus 12 times 0, and I'm about to run into my other problem, plus 13. So if I have, this is going to be 0, this is going to be 0, so I get y equals 13. So where it crosses the y-axis is going to be 0, 13. So this is my y-intercept. So we plot the y-intercept, we plot the x-intercepts, and we plot the vertex. Give everybody a chance to catch up to that point before we sketch the graph. Okay, so let's write the things down we know again. We know the vertex is 3, -5. We know the x-intercepts are 1.42, 0, and 4.58, 0. And we know the y-intercepts is 0, 13. So in order to graph, we're going to graph our graph. And we're going to count 1, 2, 3, and we're going to go down 5. this would be negative 5. So 3, negative 5 would give us our vertex. Now, going back to our original equation again, we had 2x squared as the first term, right? So if 2x squared is the first term, we know that's going to be a parabola that opens upward because 2 is a positive number. So the next thing I graph is my x-intercepts, 1.42 and 4.58, so 1, 2, 3, 4, 5, so it'd be approximately there. And then 13, I'm going to go up 13. Now we know that there's going to be the axis of symmetry that's straight down through here, so we know there's going to be another point on this side. So that point would be the same distance away, so we're going to have it be approximately right here. And then we draw in our parabola. Now, you could also check it by plugging in other points to see which ones that we have that are different points. Okay, so now we've done completing the square to get the vertex. We found the x and the y intercepts, then we graphed the graph. So the next thing we're going to do is find the domain and range. Now, we've talked about domain and range before, right? So domain and range. The domain is going to be the input, or the x. And the range is going to be the output, or the y. So looking at my picture, what's going to happen? Well, as this continues to go up, it also continues to go out to the right. As this one continues to go up, it goes out to the left. So if I go far enough out, this one is eventually going to get out here to what we call infinity. So this would be positive infinity, and this would be negative infinity as it continues to go up. So my domain is going to be negative infinity to positive infinity. Now my range is how far up and down I'm going. So down here, it stops at this point, which was our vertex. So our vertex was 3, negative 5. So what's the lowest value that for y it goes to is the negative 5, and it includes that dot. So we know that to include the dot, we're going to have brackets, negative 5. Then these arrows indicate that it goes up into positive infinity. Now, the next thing it's going to ask us to talk about is maximum and minimum. Of a quadratic function. Now we know a maximum and a minimum of the quadratic function because we've already talked about the fact that if I gave you f of x equals a x minus h squared plus k, that we know if the a is greater than 0, then we know it's going to open up. And if a is less than 0, we know it's going to open down. So what does that tell us? That tells us if it opens up, then this vertex down here is going to be the minimum. And if less than 0 opens down, then you're going to have a maximum. So this is my hk. And this is my hk. So we're going to write this one as k is the minimum at x equals h. So k is the minimum, because that would be the y value, right? How far down we go. And you're going to do the same one for this one, except we're going to say maximum. K is the maximum at x equals h. Okay, give everybody a chance to catch up to that first. Okay. So we're going to try another example of putting it in standard form and finding the maximum or minimum this time. So we're going to have an example. And the example is f of x equals 5x squared minus 30x plus 49. So it wants you to put it in standard form and find the maximum and the minimum. Now remember, we said standard form was f of x equals a x minus h squared plus k. That gives us the hk as the vertex. And it also gives us the a that we need to know whether it's going to be a maximum or a minimum. So what did we say last time? We said we started with f of x equals 5x squared minus 30x. Leave a space and put your plus 49, just like we did on the last one with the 13. So the second step was what? Second step was to take the a out of the first two terms. So I get f of x equals 5 times x squared minus 6x, still plus 49. So the next thing we do is take the half of b and square it. So half of 6 is negative 3. Negative 3 times negative 3 is 9. And put that on the inside. So if I put plus 9 inside, what have I really added though? The 5 times the 9, right? So I really added 45. So what do I have to do? I have to take that minus 45 out here on the outside. So you're keeping it even. If I put 45, I have to take away 45. So now this will factor, so I get f of x equals 5. And 49 minus 45 gives me plus 4. So I get x and x. 9 is going to be 3 times 3. Negative 6 makes negative and a negative. So now I can write my standard form. 5x minus 3 squared, because I've got 2 of them, plus 4. A x minus h squared plus k. So now we have to decide, does it have a maximum or a minimum? Well, this is a positive 5, so a is a positive 5, means that a is what? Greater than 0. So if it's greater than 0, then it opens up. If it opens up, it has a what? Minimum. And the vertex at that point, we know is going to be h and k, so h and k is going to give us 3, 4. So my 3, 4 is my vertex. So now, how do I write the minimum? So we're going to say 4 is the minimum at x equals 3. Does everybody see it, that one? So this would be my answer. Now, if I'm grading this on a test, I'd also be grading things like standard form, where you took half of b and squared and so forth. Now, we're going to go ahead and we're going to try the next one, where it's given f of x is in the other form. Ax squared plus bx plus c. So we're in that form now. if I were to take this like I did at this top, this would be ax squared minus bx plus c, and I completed the square and got this standard form down here. You can actually do completing the square on something that looks like this. So if you do completing the square on something like this, you end up with x being negative b over 2a. And that's the x value of the vertex. So negative b over 2a is the x. And then if I take negative b over 2a, whatever I get for the x value, and I plug it back into the formula, that's going to give me f of negative b over 2a is going to be my y value. So this is like my h and my k. H would be the vertex, h and k, so this is going to give us our h and k. So we're going to try one example doing it both ways. So give everybody a chance to get the formulas written down first. Okay. So we're going to try an example doing it both ways. So the first way, we're going to have g of x negative 2x squared plus 4x minus 5. Now, we know a is a negative 2 this time. So a is a negative 2 implies what? Up or down? So we know that it's going to open down, and then we're going to have a what? Maximum or minimum? Going to have a maximum, right? Because it has the highest point. All right, so to complete the square, the first thing was to move c over. Okay, the next thing was to distribute out the a. So this time I'm taking a negative 2 out, which gives me x squared. If I take a negative 2 out, this is going to make this be a negative 2 on the inside too. Now let's check that. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 2 gives me a positive 4x. So the next rule is to take half of b and square it. So half of negative 2 squared. So half of negative 2 would be negative 1. Negative 1 times negative 1 is positive 1. So I add positive 1 right here. Now, what did I really add though? Negative 2 times 1. So instead of me bringing a negative number over here, this one is already negative, we'd have to bring a positive 2 over. The opposite of the negative 2 would give you a positive 2, and they would cancel each other out. So now we're going to factor. And negative 5 plus 2 gives me a negative 3. So I get x and x to be x squared. Factors of 1 that add to be 2. 1 times 1. Negative 2 makes us negative 1 and negative 1. So my standard form, g of x equals negative 2 x minus 1 squared minus 3. A x minus h squared plus k. So my vertex, using this form, is going to be h and k. So my h is going to be 1, and my k is negative 3. All right, so that was the first method, completing the square method. So now we're going to try it by the second method. We're still using the same formula. G of x equals negative 2x squared plus 4x minus 5. So if you look back on your page, the formula, we said x equals negative b over 2a. So the vertex is going to be negative b over 2a, comma, f of negative b over 2a. So whatever we find for the x value, we're going to plug that back in to find the y value. So I get x equals, b is 4, so negative 4 over 2 times negative 2. Negative 4 divided by negative 4 gives me a positive 1. So my x value is a positive 1, which is a good thing because it was in the other one as well. So now I've got to take positive 1 and I've got to plug it into f. So I'm going to have negative 2 times 1 squared, because we're plugging it in for x, plus 4 times 1 minus 5. 1 times negative 2 gives me negative 2. 4 plus 4 minus 5. So that gives me negative 7 plus 4 is negative 3. So I get negative 3. So my vertex comes out the same in both of them. Now, be aware that they're going to ask you one specific way. So if they ask you one way, you can't do it the other way because they'd be testing your method. This still opens down. So the vertex is, we said 1, negative 3. So we have to decide, how do we write the answer? We're going to write it as what? Highest point is a maximum. So we're going to say negative 3 is the maximum at x equals 1. And then that would be my answer. Give everybody a chance to catch up to that point first. Okay? We're going to look at example number 6, page 250. It's called maximizing revenue from ticket sales. Okay, so we're going to read it from page 250. So if you have your iPads, you want to scroll to that page. It says a hockey team plays in an arena that has a seating capacity of 15,000 spectators. With the ticket price set at $14, average attendance at recent games has been 9,500. A market survey indicates that for each dollar the ticket price is lowered, the average attendance increases by 1,000. Find a function that models the revenue in terms of ticket price. Find the price that maximizes revenue from ticket sales, and what ticket price is so high that no one attends and so no revenue is generated. Okay, so we're going to look at using that example. We're going to write down first the things that we know. So the first thing we know is the seating capacity is 15,000 spectators. Oops. And we also know that the ticket price is $14. We know that the average attendance is 9,000. average attendance with $14 ticket is 9,500 people. So we're going to let X be the new ticket price. And then we're going to, so 14 minus X, if X is the new ticket price and we subtract that from 14, which was our old ticket price, that's going to tell us the amount the ticket was lowered. So this is the amount that the ticket was lowered. Okay, so 14 minus X is the amount the ticket was lowered. X is the new ticket price. So our attendance is going to be the 9,500. Since we're lowering the tickets, more people are coming in. So it's plus $1,000 for each dollar that it has been lowered. So 14 minus X is the amount the ticket was lowered. So each of those dollars that it's lowered, it brings in an additional 1,000 people. Now, it says maximizing revenue. So what does it mean to be revenue? Revenue is just the amount of money that's coming in, right? So that's going to be the ticket price times how many ever people come, right? Attendance. So that would be money coming to you, right? People buy the tickets, they give you the money, and that tells how many. So we're going to have revenue, R of X, equals X, which is the new ticket price, times 9,500 plus 1,000 times 14 minus X. So this is the price of the ticket. This is how many people are coming with that ticket price. So now we're going to simplify. We're going to go ahead and write it out and simplify it out. X parentheses 9,500 plus, and this is going to be distributed in. So I get 14,000 minus 1,000x. Now we're still inside the parentheses, so these two things right here are going to add together. So I get R of X equals X times 23,500 minus 1,000x. Now we're going to distribute in the X. So I get R of X equals, and I'm going to bring this first one out first because this is going to be X squared. So negative 1,000x squared, and then this one's going to give me plus 23,500x. So this is a squared term, so we can write this as plus 0 for our constant term. So this would be our ax squared plus bx plus c. So we're going to find out what the b is. We're going to find out what the vertex is. But first, before we find out what the vertex is, what is this thing going to look like? It's going to be a parabola that does what? A is equal to negative 1,000, right? So that means that A is going to open down, which we were hoping because it says maximizing the revenue. So we're going to take the top point. So this one is in the form x equals negative b over 2a. So our b is going to be the negative 23,500 over 2 times negative 1,000. So that gives me approximately, it may come out exactly 11.75. So what do I do with 11.75? I plug that back in to my equation here. So I get negative 1,000 times 11.75 squared plus 22,500 times 11.75, and then plus C, but C is 0. So if I simplify all that out, then I end up with what? I end up with $138,062.50 is the maximum revenue at ticket price $11.75. Now, we have one last question it asks us for. It says that at what point will the revenue be 0? Because nobody will come at all. Okay? So revenue is going to be 0 if I were to go back up to this point right here. So let's see if we can squeeze it in there. I'm going to take out of these two things, I'm going to take out a negative 1,000 x, because that's into both of them. So that would give me an x inside for this one. And for this one right here, it's going to give me minus 223.5. So if I say, when is my revenue 0, I'm going to get the negative 1,000. It's going to divide on both sides. So I get x times x minus 23.5. So x equals 0 means it doesn't have a ticket price. And the other one, x minus 23.5 equals 0, says that x equals 23.5. So when the ticket price is too high, it's $23.50. Too high. So you don't have any revenue. Sorry, that's kind of squeezed over in there. Okay? So that takes us through section 3.1, quadratic functions and models. So thank you very much.